Hello everyone, in this video we are going to discuss about our project MOOURA. You have scrolled for 20 minutes and still don't know what to watch. So the solution is MOOURA, a Serendipity-Enhanced recommendation system. The average time a user spends just deciding what to watch before playing a video on Netflix is about 18 minutes. That means for 18 minutes user just scroll videos and they don't know what to watch and what not to watch. So it basically has three mainly areas. First one is information explosion, which include 500 plus hours of video are uploaded to YouTube every single minute. Second one is analysis paralysis, 350 million products on Amazon, yet user feels stuck and overwhelmed. Third one is the same old loop, recommendation engines exist everywhere on almost every platform, still they keep showing you the same things. So for this the MOOURA is developed. Now we will talk about the pain point. Information overload is a real crisis. This is the main reason why you got many recommendations, still you are not able to decide what to watch or not. So the problem and their impacts are mentioned here. For example, information overload is the problem and its impact is decision fatigue or poor UX. Next problem is repetitive recommendations whose impact is filter bubbles, low diversity. Third problem is cold start problem and its impact is high dropout rates. Next problem is popularity bias, which impacts revenue loss for creators, mainly for small creators, because due to popularity bias of big creators, small creators content doesn't get popular, which causes revenue less to small creators. Now 70 to 80% watch time driven by recommendation engine algorithms generated 35% total revenue generated directly from product suggestions. Trapped user sentiment, user feels stuck seeing the same content loop. So our research question is, can we make recommendations both relevant and surprising? Our core search question is, can a hybrid recommendation system improve serendipity scores by 2x while maintaining accuracy using a modified BPR loss function with popularity penalties? Whose three sub questions are related to accuracy trade-off. How does adding a popularity penalty to BPR affect precision at the rate k and recall at the rate k? Second is related to content diversity. Can an LP based embedding enhance content diversity without sacrificing relevance? Third one is related to quantifiable gain. What is the measurable serendipity score improvement over baseline models? Now the solution is MOOURA. So MOOURA is a recommendation that surprise you. Core insight of MOOURA is most system optimize for accuracy. They repeat what you have already seen. MOOURA optimizes for serendipity plus accuracy. So it do mainly four tasks: collaborative filtering, content based NLP, serendipity engine, fast retrieval. Now system architecture workflow of MOOURA is, first you give data input or user history plus metadata is used as a data input. Next it goes to CF layer or NLP layer. CF layer do matrix factorization while NLP layer does content embeddings. Next it goes to hybrid fusion where it weightedly combine all the content and then filter it. Next is serendipity ranking, modified BPR loss. Next one is output surprising recommendations. So before using traditional, without using MOOURA, action, action, action. Now after MOOURA, action, drama and hidden gem. Now the methodology or the research design of MOOURA: rigorous multimodal data driven, a comparative algorithm study testing a hybrid architecture against traditional baseline to quantify serendipity gains. So data sources are MovieLens 10 million, MovieLens 32 million, TMDB plus IMDb. Now we have differentiate something on the basis of phase, duration and activity. For example, literature review, duration month 1 to 2 and activities are survey, CBF, CF, NCF and BPR optimization methods. Next phase is data pre-processing and its duration is almost 1 month, which is from second month to third month. And the activity will be ID mapping across sources, cleaning, feature engineering. Third phase is model development. It also takes 1 month. And the activity done in this phase is implement SVD, SVD++, BPR, and 2 tower neural models. Next phase is Serendipity Enhanced, which takes around 2 months, from 7 months to 9 months. And the activity done in this phase is modify BPR loss function with popularity penalty term. Next phase is eval and validation, and its duration is approximately 3 months, from 9th month to 12th month. And the activity done in this are compare precision at the rate k, recall at the rate k, and SRDP at the rate n metrics. So the algorithm tested are SVD, SVD++, BPR, BPR plus serendipity, 2 tower neural. Now, strategy validation or the evidence. This approach is grounded in proven research. So we have also it tabulated the information in the form of validation type as a column, evidence, and confidence. So pilot results, literature support, technical feasibility, dataset validation all have high confidence, while serendipity research has a medium confidence. Key proof points of research are 70 to 80% watch time driven directly by recommendation algorithm, approximately 35% total revenue generated from frequently bought together, and BPI is greater than SVD methodology. Pairwise ranking is mathematically superior for implicit feedback. Now, 12-month research roadmap from concept to publication. So, quarter one or for first 3 months, our key milestone will be foundation and data pipeline, which include literature review complete, dataset acquired, pre-processing pipeline built. For next quarter, that is for next 3 months, our key milestone will be baseline model development, that is SVD, SVD++, BPR models trained and evaluated, baseline metrics established. For next 3 months, our key milestone will be serendipity and NLP integration, which will be our core innovation. BPR serendipity enhancement implemented, NLP pipeline integrated, and for next or last 3 months, our key milestone will be advanced neural models and output, which include 2 tower neural model trained, full evaluation, paper written and submitted. So milestone categories are related to research, scaling, and output. Now, how can success be measured in this or the success matrix, smart matrix dashboard, measuring what actually matters? So we have also tabulated the information into 4 main columns: metric, baseline, target, and how measured. So metric include precision at the rate 20, recall at the rate 20, serendipity, item coverage, bubble reduction. So mainly 5 points it covers, and corresponding to these 5 points we have baseline, their targets, and how they are measured. So key achievement already reached are 2x serendipity boost, that is SRDP at the rate n improved from 0.09 to 0.19 in pilot tests. Recall gains, BPR model reached 0.55 recall at the rate 20, outperforming SVD baseline significantly. Now we will discuss about the team or the execution capability, researchers behind MOOURA. So we have basically 4 roles in MOOURA, that are ML engineer, data engineer, NLP specialist, and evaluation lead. And technical skills and contribution corresponding to them are mentioned here. Now we will discuss about the risk mitigation, or we have planned for what could go wrong. So the possible risks are data sparsity, cold start for new users, serendipity versus accuracy, phase scaling issues, overfitting neural model. These are the mainly 5 risks that can come while using MOOURA. So we have tabulated the whole data into 4 columns, that is related to risk, probability, impact, and mitigation strategy. Probability is how much it is probable that this risk will be happen, and when this risk happens, what will be the impact, and how can we resolve this risk. All the things are mentioned in the table. We also have a pivot plan. If serendipity gains is less than threshold, we will pivot to graph neural networks to capture higher order connectivity for non-obvious recommendations. Now what we need to scale MOOURA. Total funding of 5 lakh rupees fully allocated for 12 months is required to scale MOOURA, and how this fund will be divided is clearly mentioned here. So expense, we have divided various expenses into different categories, that is personal or stipend, cloud compute or GPU, data and APIs, publication fees, and miscellaneous. So during first 6 months, personal expense category will be around 40%, cloud compute will be 30%, data and APIs will be around 15%, publication fees will be 5%, and miscellaneous will be 10%. While during last 6 months of the project, personal stipend will be 35%, cloud compute will be 25%, data and APIs will be 10%, publication fees increases to 20%, and miscellaneous fee still remain to 10%. Now we'll discuss about project ROI, helping content platform reduce decision fatigue and surfacing long tail content creator to increase catalog utilization. Now we'll also discuss about sustainability, open source release on GitHub, potential SAS API for streamers. So investors, fund the future of personalized discovery. Why now? The streaming market is growing 15% annually. The window to lead in serendipitous AI recommendations is now. What your investment unlock? Help millions of users discover content they would genuinely love. Provide streaming platform a proven open source serendipity engine. Contribute to cutting edge academic research in AI/ML. Support the next generation of student researchers. Next steps for backers are: schedule a conversation, review technical proposal, fund to enable Q3 training. That's all related to MOOURA. Thank you everyone.